So hi everyone, my name is Decadet John Lawrence Bacaso and I'm going to show my rider plotting. So hi everyone, I'm going to show you or demonstrate to you how I answered for the TCPA, CPA, and the target speed and also the aspect. So let's begin. So the first thing that I did was to plot these three targets. So target 1, 2, 3, and then this is the O or the original, and then there's the actual. So first I did was plot. So the target one has a bearing of 40 nautical mile with a range of 8. So this ring has corresponding 2 nautical miles. So 2, 4, 6, 8. So meaning that the target one is in 8 ring or 8 nautical mile. So the second one has still the bearing of 40 degrees and the bearing of 6. And the third target is within the bearing, still with the bearing 40 degrees and a closer range of 4. So this is from 177 and 1706 and 17012. So that means from O to A it has an interval of 12. So first is you create a line from here to here. So from O to here, from the passing of our ship, this is what you call RML or the related motion line. So next one is I proceed to in finding the TCPA. So here CPA, or also called as the closest point of approach, since that we don't have a closest point of approach because risk of collision exists in the scenario, I move to TCPA because we don't have a CPA, so the CPA is 0. So TCPA, so this is the formula for TCPA, 0.2 times 4 nautical mile divided by 4. So where did I get that? So the 0.2 is the time, so or also known as 12 minutes. So I converted it, and 12 minutes is 0.2. So next one, the 4 is from O to A. As you can see, I'm having a hard time because I'm using one hand. So from O to A, it traveled 4 nautical mile. So the next one, the other 4, from A to our ship. So from A to our ship, it also traveled 4 nautical mile. So 0.2 times 4 divided by 4. So I cancel out nautical mile to have the R. So 0.2 R, and then convert it to minutes. So it is 12 minutes. So within 12 minutes, risk of collision exists. So the next thing that I did was to find the speed. Oh, before you find the speed, you're going to solve for the W. So in answering W, our ship is this is our course, our own ship course. We have own ship course of 300. So from our ship's course and our vector has 2 nautical mile. So from our vector, we're going to move to W, right? Just like that. But it's a bit accurate because I'm using one hand. You're going to, but still with 2 nautical mile. So that will be your that will be your W, and then create a line connecting W and A, and also O and W. And then the next one is this target course. So from W to A, I also drag this like that until it reaches the middle. So the target course is 342. So next thing is to find the speed. So this is the formula. Speed is equals to time times distance. So we all know that from O to A, if I'm from O to A, the target moved 4 nautical miles. So 4 nautical miles within 12 minutes interval. So that will be the 12. So 96 knots. So bear with me because this is just an example. But in actual, 96 knots is a very speed vessel. But this is just an example just to show or demonstrate on how to find TCPA and CPA. And then the next one is we have the CPA and TCPA. So the next one is I'm going to find for the aspect. So in finding the aspect, you're going to create a straight line from O to here. So it has a bearing of 220, but you're going to minus it to the target course or the target score. So 220 minus 342. So the aspect is 122 degrees. So so I believe that that will be also in this scenario or situation, risk of collision exists, but I didn't add how to alter course because it is not in the example. So it might be on the next discussion or next video. So once again, we have a TCPA of 12 minutes and the target speed of 96 knots and the aspect of 122 and 0 CPA. So once again, I am Decadet John Lawrence Bacaso and thank you for watching.